Imagine you've got an old transformer welder, perhaps from the early 90s, sitting idle in your garage. You decide to try welding a piece of steel, but something's off. The electrode barely ignites and then sticks to the metal, indicating insufficient current. Even cranking up the amperage doesn't solve the issue. Curiously, when you use the same welder at your uncle's garage, it works flawlessly without any noise or vibration. But back in your garage, the electrode sticks, doesn't melt, and the welder vibrates. What's causing this discrepancy? Could it be your electrical setup? Let's dive into the physics behind voltage drop and how it affects welder performance. Voltage drop is a critical concept to understand when dealing with electrical systems. Imagine you're sending water through a long hose. The further the water travels, the more pressure it loses. Similarly, as electricity travels through wires, it loses voltage due to resistance. This loss is more pronounced over longer distances or with thinner wires. The key parameter here is resistance, measured in ohms. The longer the wire, the higher the resistance, leading to a greater voltage drop. To calculate this, use Ohm's law, V equals IR, where V is voltage, I is current, and R is resistance. If you're experiencing issues with your equipment, like the welder in our example, a voltage drop could be the culprit. Measure the voltage at both ends of the circuit to confirm. To configure your welder, start by understanding the importance of voltage and current settings. The voltage drop over long cable runs can significantly impact performance. Ensure your input voltage is stable. Set your welder to the recommended voltage range, typically between 220 to 240 volts for optimal performance. Next, adjust the current setting. For a Telwin transformer welder, begin with a mid-range amperage, around 60 to 80 amps, and fine-tune based on the material thickness. Remember, higher amperage requires thicker electrodes. Also, check the electrode holder's connection. A loose connection can cause performance issues. Lastly, ensure your power source is clean and free from fluctuations, as this can affect the welder's stability. To accurately measure voltage, you'll need a digital multimeter. Start by setting the multimeter to the AC voltage setting. Connect the black probe to the common port and the red probe to the voltage port. For safety, ensure the multimeter is rated for the voltage you're measuring. Place the probes on the terminals you wish to measure. The display will show the voltage reading. Remember, voltage can fluctuate, so take multiple readings over time. If the voltage drops significantly during operation, it indicates a potential issue with your electrical supply. Now, let's delve into the practical solutions for mitigating voltage drop. The first step is to calculate the resistance of the cables you're using. Imagine your cable is a long resistor. The longer it is, the higher the resistance. Use the formula R equals rho LA, where R is resistance, rho is the resistivity of the material, L is the length, and A is the cross-sectional area. Once you have the resistance, you can calculate the voltage drop using Ohm's law, V equals IR. If the voltage drop is significant, consider upgrading to a thicker cable with lower resistance. Another solution is to move the power source closer to the load, reducing the cable length. Additionally, ensure all connections are tight and free of corrosion to minimize additional resistance. For more precise control, you might consider using a voltage regulator or a transformer to stabilize the output voltage. Remember, the goal is to maintain a consistent voltage at the load to ensure optimal performance. Let's dive into common pitfalls when debugging voltage issues. First, ensure your multimeter is calibrated. A miscalibrated multimeter can give you false readings, leading you down the wrong troubleshooting path. Next, pay attention to voltage drop. Long cable runs can cause significant voltage drops, especially with high current applications. Measure the voltage at the source and at the device to identify any discrepancies. Another common mistake is not accounting for ambient temperature. Voltage readings can vary with temperature, so make sure to adjust your readings accordingly. Lastly, double-check your connections. Loose or corroded connections can introduce resistance, causing voltage issues. Tighten connections and clean terminals to ensure a solid connection. Remember, accurate voltage measurement is crucial for effective troubleshooting.